Lester, Wushu Engineer. I wanted to start off with a full disclosure by saying that I made this video with the goal of advertising and selling certain commercially available stab and slash defense armor products on my Wushu workshop website. I had every intention of showing you how well the modern knife armors work and then putting up a range of new products on my website and rolling in a couple of much needed dollars. However, what started off as an advertisement quickly devolved into what I can only describe as a buyer beware public service safety announcement regarding some of these cheaper products. I'm sure this video is going to attract some negative attention from some of the suppliers. Even though I have not identified the manufacturers in this video, it wouldn't take a rocket scientist to identify the types of products from the images I've shown on this video. But dadgummit, I would not want to have my life dependent on some of these systems. You, the public, have a right to know. I want to warn you that this video is a lot longer than usual because there's a lot of information I had to get through. But skip sections at your peril if you depend on stab and slash resistant armor in any way. So on with the video. Many martial arts schools and self-defense systems, such as our own, offer various types of bare hand knife defense. It is important to practice methods and techniques that can increase the odds of the defender surviving this kind of encounter. However, this type of encounter, a bare hand defender against an armed attacker, is very much skewed in the favor of the attacker. Bare hand defense against any kind of weapon could be considered an absolute worst case scenario. It is hard to describe just how dangerous this situation is, and the level of danger increases exponentially with increasing attacker skill. A skilled knife fighter is incredibly dangerous if the defender is barehanded. For those martial artists who step outside of the simple technique practice into freestyle sparring against skilled armed opponents, armed with training weapons of course, this observation will come as no surprise. This is why every attempt should be made, if at all possible, to even the odds somewhat by using whatever makeshift weapon of opportunity might be at hand. A good choice is any kind of reach weapon, such as a club equivalent that might give a range advantage over the knife so that there is some chance of striking and stopping the attacker at a longer range before they can close to their optimal range with a blade. Another good choice is some kind of shield, such as a bag or a wrapped up item of clothing. This won't provide as much of an advantage as a reach weapon, but it can certainly enhance defense, potentially allowing the defender some limited opportunity to launch a decisive counterattack. YouTubers such as the Metatron have correctly raised the issue of the difficulties associated with knife defense. I will leave a link to his video in the description below. Check it out. His channel is an excellent resource. His conclusion was that in a situation where one is facing a knife-wielding attacker, some form of body armor can make a critical contribution towards your survivability. This is a sentiment which I wholeheartedly agree with. In fact, with modern fears about knife crime and school-based hostage situations, I read an article recently about how Aussie parents were buying discreet knife armor systems for their children. It was from the Sydney Morning Herald and was published in 2007, and the article was entitled Aussie Parents Ordering Stab-Proof Vests. They were apparently opting for the fabric-based systems as used in t-shirts and the like. If you're one of those parents, please pay attention to the contents of this video to understand what type of protection you have actually purchased for your child. As it turns out, most modern armor systems are just not up to the task of stopping a decisive knife thrust. Scalagram, another excellent YouTuber whose channel is well worth checking out, just follow my link in the description below, has performed several practical cut, slash, and stab tests with available fabric knife-proof armor systems, in inverted commas, of course, with very disappointing results. These armor systems are typically made using Kevlar, Spectra, or Dyneema weave. These fabrics, while incredibly strong and tough, are just not tough enough to resist the sharp cutting edge of a knife. In fact, the pad of Kevlar fabric that makes up a typical level 2 or 3A soft ballistic vest, in other words, a bulletproof vest, is not able to prevent penetration by a knife. So let's just imagine for a minute that there is a mythical fabric that was tough enough to withstand cutting by a knife blade. What would happen to the wearer of the armor made from this fabric if they were stabbed? Even if the knife did not penetrate our mythical fabric, if the fabric was not thick and stiff enough, it would gather around the knife, and the knife, wrapped in the fabric, would continue on its trajectory into the wearer's body and possibly penetrate the skin and flesh anyway. It would thus still pose a significant threat of injury or even death to the wearer. There are commercially available systems which are fully certified, but they are typically extremely expensive and often bulky. The following information is from the www.bulletproofme.com website, a site that sells various forms of modern armor. We're in no way affiliated with them, nor do we receive anything from mentioning them. The only reason I'm mentioning them here is that they have some good information on their site, so check it out. The website gives a good description of the NIJ, or National Institute of Justice, stab threat rating system, one of the rating systems used to rate stab-resistant armor. The NIJ rates body armor on resistance to hand-delivered stab threats, which is the NIJ standard 011500. Slash threats have been found much easier to defeat than stab, and thus are not specifically addressed by this standard. So maximum penetration of 7 millimeters is allowed, as serious injury is extremely unlikely with such a shallow wound. Of course, I myself would prefer 0 penetration. Also, an over-test is applied to push the breaking point of the armor where 20 millimeters of penetration is allowed. Testing is done in two different categories of threat: high-quality commercial knives called edged blade, and prison-style improvised spike weapons. The levels of energy which are used in the NIJ test are as follows. There are 3 threat levels that are tested for in the NIJ tests. The first involves a penetration limit of 7 millimeters of 24 joules and an over-penetration limit of 36 joules. The second level involves a 33 joule penetration, 7 millimeter penetration limit test, and then an over-penetration limit test of 50 joules. The level 3 test involves a test of 43 joules and then 65 joules. A stab-proof vest will protect you from, and this is still according to the bulletproofme.com website, a stab-proof vest will protect you from the vast majority of hand-delivered knife and spike threats you are ever likely to face. But there's always a trade-off between more protection and more wearability, and the constraint to stay within the budget. In addition, they state that axes, hatchets, adzes, digging picks, claw hammers, crowbars, bayonets mounted on rifles, spears, lances, unusually strong pressure or force behind the stab, blow, and or other unusual weapons or situations can defeat any stab-resistant body armor. I beg to differ on that, because I believe that it is possible to produce an armor system that can resist just about any human-powered threat in terms of stab resistance. But I'll have more on that later. They also go on to say that also at some angles, weapons can slide or deflect off the edges of body armor. Furthermore, impacts that are successfully supported by the vest will always produce some level of injury, resulting in severe bruising, broken bones, and possibly serious internal injury or even death. Stab-resistant vests defeat most common threats, but no vest on earth makes you invulnerable. To state the obvious, getting stabbed always carries some risk. There are, however, a lot of cost-effective solutions that are currently available that all claim to offer some level of stab and slash protection. I decided to put 5 of these systems to the test, 2 fabric-based systems based on Kevlar and also on ultra-high molecular weight polyethylene, or UHMWPE. I don't know whether you would really be saying that as umwapa. Anyway, UHMWPE. 2 systems incorporating rigid plastic plates, and 1 system incorporating flexible high-strength steel sheets. So I have a few materials that I'm going to be investigating in this stab and cut-resistant Armour video. The first material that we're going to be investigating is commonly available, that is commonly available in various forms, whether it's upper body garments, pants, gloves, various items of clothing, is called HPPE, or ultra high molecular weight polyethylene. I have a sample of it here. So the company that we approached was kind enough to send us a sample. Most companies were prepared to send us a sample for testing, so that's really great. So we'll be testing this in terms of its slash and stab resistance. The second type of armor that we're going to be testing is just to reiterate, this is, as you can see, this is a fabric and has no rigid elements in it at all, so it's completely fabric based. This is also made out of various types of plastics. This is a polymer reinforced material made out of a para-aramid fabric. You'll notice that it has lots of, or you might be able to see that it has lots of tiny little squares of rigid plastic embedded or welded or glued onto the fabric. So it's very much like a type of modern day brigandine, if you like, made out of composite plastics and aramid. So we'll be testing this for its stab and slash resistance. While I'm at it, I'll show you a close-up of the polymer or plastic reinforced aramid fabric as well. As you can see, lots of tiny little square reinforced plastic plates, quite flexible in both axes. Another type of material that we're going to be testing, I have an example of it here in these slash resistant sleeves, cut-proof sleeves, or what they claim to be cut-proof sleeves, also made out of an aramid or Kevlar fabric. So this is just plain aramid, woven aramid or Kevlar fabric. We'll be testing these. And lastly, the last product that we're going to be testing is a steel stab-proof material. So this is made up of lots of small rectangular plates of high hardness manganese steel, very thin. So actually surprisingly light. It's a surprisingly light garment. Not particularly flexible though, and quite bulky. The material, the steel is protected by layers of foam padding which bulk it out a little bit. And if I put it on so that you can see what it looks like. Not particularly covert, and as I said, not particularly flexible either. Although, again, very much based on a modern day interpretation of the brigandine approach to armor, which is little metallic pieces that are sewn into cloth. But quite a relatively low budget option. So these the options This option is fairly pricey in terms of stab and slash resistant. The Kevlar is fairly cheap, and so is the polyethylene. But we'll test these out and we'll see how they do. So I thought I'd show you just a bit of a close-up of what the steel Armour looks like on the inside. So these are the plates, very thin, not particularly flexible, and actually a little bit razor sharp on the edges, so I'm going to be a bit careful with that. Covered in a foam pad, both front and back. Well, this was a bit of a late entry, so this will be the 5th type of knife slash and stab protection that I'm going to be testing. Similar to the other systems that I've shown you, this, if I've cut one of the pieces open so that you can see what's inside. You can just about make it out there. There are some, if it focuses nicely, you can see a tiny circular plates that are bonded onto a fabric backing. Those are a type of plastic. I'm not sure exactly what kind of plastic, but possibly it might even be a fiber reinforced type of plastic. So we'll test this system as well. We bought a sample, well, not a sample, but we bought a neck guard. So I'm going to be chopping that up into 3 pieces for testing. These solutions are generally either based on high tensile strength fabrics or on rigid metallic or composite plates embedded in fabric layers, very similar to medieval brigandine armor. The use of rigid articulated plates allows much greater resistance to cutting and stabbing because the knife blade has to cut through dense, solid material instead of having to merely cut thousands of fine fibers. I wanted to perform 3 different types of tests for each system: a draw cut, a slash, and a stab. For the draw cut and slash, I used my Tora blades, Tora KTM British Service issue circa 1970 kukri. For those of you who are into traditionally made Nepalese kukris, I highly recommend Tora blades, who make outstanding kukris after the traditional patterns. The wait can be longer because they are made by a traditional kami to order, but it's certainly worth the wait. Their website is torablades.com. We also don't receive any sponsorship from them. I'm just mentioning them because they happen to make very high quality kukris, which I quite appreciate. For the more damaging tests against the steel sheet armor, I used my cold steel Magnum kukri machete, which is my general purpose workhorse for various destructive tests. So these are the 2 knives, in inverted commas, that I'm going to be using to do some of the slash tests on the armor samples. I'm typically going to be using this, which is my Tora Blades kukri, and I'm going to use the cold steel Magnum kukri machete when I have to do testing against armor samples such as the steel plate armor that will potentially damage the blade of the knife, because I don't want to damage my Tora Blades kukri. For the stab tests, I built a hanging wooden block dummy, which will hopefully form the basis of a future weapon play dummy. Perhaps it'll feature in future videos. Actually, I'm pretty certain it will. So this is the hanging wooden dummy that I've set up to do the stab and slash tests. Simple, but it works. The advantage of having a hanging dummy is that it reacts to a strike in much the same way as a human body by being pushed out of the way, absorbing some of the force and energy of the movement. In its movement. I was originally just going to do the stabbing myself, but this would have been very difficult to standardize, So I built a pendulum test rig that could be used to obtain fairly consistent forces and energies. So this is the pendulum test rig. This is the section I've just bolted onto the side that allows weight to be added. I have used a total of 5 kilograms on this bar for these tests. And you'll see the mounting bolt at the top, which allows it to swing, along with a rough and ready angular measurement so that I can quickly see what angle I'm holding the pendulum at before I drop and allow it to do the stab test. The length is roughly 1.3 meters. The whole rig itself, without any added weight, is about 4 kilograms, and as I said, a total of 5 kilograms was added to the bar. So for the purposes of doing energy measurements based on the old pendulum equations of kinetic and potential energy, I have made a very gross assumption that all of the weight of the pendulum is resting at the bottom, so a total of 9 kilograms. That is, of course, incorrect. It is just a gross approximation, just to simplify the calculation. So, so this is what I've prepared for the stab tests. It's a sharpened table knife. I wanted to do it that way because I didn't want to damage any of my knives in terms of the stab test. So we'll see how this holds up, whether it's just going to fold or whether it's going to do its job. I did a series of tests using my load cell to measure the impact forces of the test rig from 25, 35, 45, 55 and 65 degrees of pendulum angle. Note that the load cell was free to move in this case and was not rigidly mounted. Additionally, I did not have a knife blade mounted on the end of the pendulum during these tests. Duh. But rather a foam pad, because I value my load cell. It was expensive. So the average impact forces from these tests were, for 25 degrees, 284.6 newtons, for 35 degrees, 482.6 newtons, for 45 degrees, 744.4 newtons, for 55 degrees, 965.6 newtons, and for 65 degrees, 1,346.6 newtons. Based on the gross approximation that the weight of the pendulum, all of 9 kilograms including the 5 kilogram weight at the base, is all concentrated at the bottom of the 1.3 meter arm, and applying the old potential energy is equal to mass times the acceleration due to gravity times the height, the height of elevation of the pendulum. We can calculate I calculated the following kinetic energies at the point of impact. So at 25 degrees, the energy at the point of impact would have been 10.7 joules. At 35 degrees, 20.7 joules. At 45 degrees, 33.6 joules. At 55 degrees, 48.8 joules. And at 65 degrees, 66.2 joules. I then performed the draw, cut, and slash tests against the Armour samples. The Kevlar cloth performed very poorly, even against static draw cuts. However, the ultra-high molecular weight polyethylene, or UMWPA, cloth performed surprisingly well, only receiving some nicks on the areas of cloth at the edge that were folded over and thus raised, which concentrated the cutting over a smaller surface area. All three systems incorporating rigid plates performed well against the draw, cut and slash. However, I had some doubt regarding the ongoing effectiveness of the Armour incorporating the little circular plastic plates. I believe it would break down much faster than the ultra-high molecular weight polyethylene, or UMWPA. Further testing may be required here to confirm this. The overlapping rectangular plastic plates and the steel plates performed very well with no appreciable degradation of the armor. I then went on to perform the stab tests for each system, starting at 25 degrees and then working my way up in 10-degree increments if the armor held. Predictably but disappointingly, both cloth armor systems failed at 25 degrees, representing an impact force of approximately 280 newtons and kinetic energy of just over 10 joules. That's a lazy Sunday afternoon knife thrust. Anyone who is depending on cloth-based armor systems for stab protection, be warned about this. It will not offer you anything in the way of legitimate stab protection. If you want stab protection of any reasonable level, you need to go for a hard armor system, the modern equivalent of brigandine armor. I then proceeded to test the hard armor systems. The armor incorporating the little circular plastic plates failed disappointingly at 25 degrees, representing an impact force of approximately 280 newtons and a kinetic energy of just over 10 joules. I expected it because there were significant gaps between the circular discs, which under any kind of pressure would more than likely move out of the way and allow the blade to penetrate the cloth backing. So I've taken this section of armor apart just to show you how the penetration occurred. So if I open it up here, you can see that the penetration occurred there and chopped part of one of those plastic tiles off in the process as it moved past. Obviously deflected off that plastic tile. And this is exactly what happened. In fact, what happened was that the knife blade actually chopped a small piece off one of the circular discs on its way out. What was most surprising and disappointing to me was the performance of the armor incorporating the rectangular overlapping plastic plates, which failed at 35 degrees, representing an impact force of approximately 480 newtons and kinetic energy of just over 20 joules. I had really expected this to go the distance and was really hoping to sell this product on my website. Oh well. It seems as though the industry is missing a key intermediate non-metallic solution to the problem of knife-proof armor. This is what inspired the Metatron to recommend the use of mail armor in his video. In his case, a riveted steel mail vest worn under his shirt. This lack in the industry is incredibly disappointing to me, because there are certainly materials and methods that could be applied to produce a knife-proof armor that would be lighter and more effective than mail armor. On to the steel brigandine test. The steel armor performed exceptionally well. I tested it all the way up to 55 degrees, representing an impact force of approximately 960 newtons and kinetic energy of just over 48 joules, with no penetration or degradation to the armor at all. This is well in excess of what the system has been officially tested to. The manufacturer stated that it had been tested using some Chinese standard, which I'm unfamiliar with, in a test involving 24 joules of kinetic energy. I seriously doubt that it would be possible to penetrate this armor using large knives. It may be possible, though not easy, to slip under the armor sheets as they deform, but the angle of the blade in that case would probably not be able to harm the wearer below. One thing that I will say is that it worked very effectively to deflect the incoming blade. This may deflect the incoming blade onto an unprotected area of the wearer, but this does not represent a design flaw of the armor itself. So I will be very happy to stock this item on our Wushu Works workshop website for those who are interested in owning one. It also happens to be quite cost effective. So of all the armor systems, none of the plastic or composite systems went the distance. This was really disappointing to me, because I know that full protection can be achieved based on my own experiments. So I decided to test a small sample of the composite plastic ceramic armor system that I have been incorporating into my functional samurai jacket build. See my samurai jacket videos for further details. I had a lot of confidence in my design, so I just went straight to 55 degrees in my test, and this is what happened. Dramatic! Isn't that amazing? There is no way that a human-powered weapon system will breach that particular armor design. Hi, I'd just like to interject at this stage, if I may, just to say that making very bold, sweeping statements like that is not the way of an engineer. I was beside myself with excitement. So I would like to retract that and say rather that it is quite possible that it would be very difficult indeed using handheld weapons and normal human power levels to penetrate that kind of armor. So anything is possible in this world, really, given the right amount of resources, time, and given the right type of design. So it is quite possible that a human-powered weapon would be able to penetrate that kind of armor, but it would be quite difficult. I designed it to be that way. The other thing that I'd like to mention at this stage as well is that the reason that the knife blade snapped during the test of my armor sample was actually a design feature of the armor that I mentioned in my previous functional samurai jacket videos. And that is that I've designed the armor to prevent the weapons from actually deflecting off the armor, and rather to essentially capture the weapon, deal with the incoming energy at that point. And that's essentially why the blade snapped rather than skittering off, which is what occurred when I was testing the steel sheet armor. So on with the video. That's definitely the type of system I would want to be wearing if I was in harm's way. Now, some of you may be saying that the energy levels and force levels applied in these tests are quite high. You will probably not face an opponent using this kind of force. Well, I beg to differ. To put things into perspective, I will show you an excerpt from my older 1-inch punch video, which involved a punch from just a few inches away from the load cell.
824, 995, 1035, 913.
This 1-inch punch generated just over 1,000 newtons of force, similar to the 55-degree pendulum drop. In fact, if I show you a comparison of the waveforms, you will see that they are so similar as to be almost identical. What is scary is that this kind of force and energy can be achieved easily with an edged weapon without any kind of drawback movement and with hardly any room required for acceleration. Also shown on the graph is a waveform from a back fist strike performed on the load cell, showing the high impact forces that can be achieved with this. That can also be transmitted into a bladed weapon. This represents impact forces and energies that are many times higher than those applied in the stab tests. So these kinds of impact forces and energies may not be as rare out on the street as you think. So to wrap this video up, the cheaper systems offer reasonable protection against slashes, but almost no protection against stabs, with the very notable exception of the steel sheet brigandine armor, which we'll be putting up for sale on our Wushu Workshop website. I hope you enjoyed this video. Leave a comment, a like, and please subscribe if you enjoy what I do. It helps this channel. I'll see you next time. Cheers!